All right, now we move on to finding arc measure in section 10.2. And just like the first section, we have to go through some definitions so that you're familiar with these terms as we're using them throughout the section and through the rest of the chapter. The first thing we're going to deal with is a central angle, and it's really simple. It's an angle whose vertex, meaning that center corner angle, if we draw any angle, this is the vertex, whose vertex is the center of the circle. And you'll notice in this case, we've drawn a central angle of ACB. Then there's something called a minor arc. And a minor arc is very simple. It's the arc formed by a central angle whose measure is less than 180. In this case, arc AB is the minor arc. And the reason it has to be less than 180 is because anything at 180 is called a semicircle. Anything more than 180 is called a major arc. And that takes us to the next term, major arc. Points of a circle that don't lie on a minor arc. Really simple. If it's a minor arc, then everything else is a major arc. In this case, major arc A, D, B. You'll notice the terminology or the nomenclature here. We name minor arc AB using only 2 letters. We use 3 to designate a major arc. Okay? You want to go major arc ADB, because if you said major arc AB, you might get that confused with minor arc AB. And then something that's not too hard to understand is something called a semicircle. And a semicircle is an arc with the endpoints that are on the endpoints of a diameter. If we were to take this circle that we've already got drawn and we were to draw a diameter, boom, diameter. Any half of this would be a semicircle. Hopefully that makes sense. Okay, go to the next page. And now we're talking about measuring arcs. The measure of a minor arc, remember a minor arc is less than 180, is the measure of its central angle. Really simple. The arc is equal to the angle. The measure of the arc is equal to the measure of the angle. In this case, in our little drawing down here, angle ACB equals 50 degrees. Which means that arc AB also equals 50 degrees. They're the same. Just like it takes 360 degrees of an angle excuse me, to make up the inside of a circle, it takes 360 degrees on the outside edge. So if you've got an angle that's 50 degrees in the center, the arc that has covered has also spanned 50 degrees too. And we're going to talk about spanning when we get into class next, because spanning, talking about how much something has actually rotated, is different than an actual angle. So let's next go to a major arc. Now, if a minor arc is this small acute angle, then everything else is the major arc. Now, the major arc is just 360 minus the minor arc, meaning, excuse me, if this angle is 50 degrees, how much is this angle? Well, if the whole circle is 360 and 50 of that has been taken by the minor arc, then the rest of it is 310 degrees. This arc right here is 310 degrees. So we could say that the arc ADB equals 310 degrees. Notice again that we use 3 letters for a major arc and only 2 letters for a minor arc. Let's go to example 1, and it says, find the measure of each arc of circle P where RT is a diameter. Well, let's first go through and identify our arcs. We have arc ST, and I'm going to make sure that it's an arc symbol, not a line segment symbol. We have arc RS. We have arc RT. And then we could do a couple combinations. We could say major arc SRT, and we could say major arc STR. And you're going to notice that those are different depending on which direction you go. Now let's first start solving for these minor arcs. They told me already that this arc is 110 degrees. And they also told me that RT is a diameter. Now, let me ask you this. What span or what degree is a diameter? Hopefully you know that it's 180 degrees, which means that from here to here is 180. Well, if this much of it is 110, what's left? What is minor arc ST? Hopefully you know it's 180 minus 110, or 70 degrees. And they already told me RS is 110. So we've got these two little minor arcs out of the way. Now let's get to the major arcs. We could figure out what RT is, because RT is a diameter. And if you have a diameter, the arc formed by that diameter is something called a semicircle. And a semicircle equals 180 degrees. But then we get into SRT and STR. Now those are different, even though they're using the same letters, they're different based on which direction you go. And what I mean by that is this. Both of them start at S. One of them goes SRT, and one of them goes STR. So you'll notice that they are not exactly the same angles. Now I already knew that this is 70 and this is 180. So now I just need to figure out what these two major arcs are. First I'm going to do SRT. SRT. And I'm going to close off those angles. You can see that the highlighted arc goes from here to here and then here to here. Now the inside of that angle is 110 and 180, which means that the arc also has to go through 110 and 180, which means that the arc is actually 290 degrees. The arc and the angles are the same degree. Now let's look at STR. STR goes from S to T and then to R. And we already knew that this was 70 degrees and this was 180 degree. So when I close off the angles, it goes from here to here, so it spans 70, and then from here to here, which is another 180. So I can add up 70 and 180 and get 250 degrees. Hopefully that makes sense on how to find those major and minor arcs. Let's go to the next page, and we're getting to something called the arc addition postulate. Now you've already seen the segment addition postulate. You've already seen the angle addition postulate. It's the exact same thing. All it says is the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. And what that means is if you take like arc AB, add it to BC, and then to CA, you add up all of those arcs and you get the whole circle ABC. Now, by the way, what other postulates does this remind you of? You've seen it about 1,000,000 times. It's the other addition postulates. It's just we can apply those addition postulates to really anything in geometry. But if you look at example 2, we go through and we find out this is a pie chart. And we know that this pie chart designates each section by percent. Or excuse me. Yeah, that should be percent, not degrees. Let me change that. And you should change it too in your notes. Those should be percent symbols, not degree symbols. because obviously it wouldn't add up to 360 degrees. Well, now what we need to do, though, is find the measure of the indicated arc. Now let's look first at arc AB. It's right here. Arc AB is equal to this angle that forms arc AB. And the angle is 25% of the whole pi. Well, what I want to do is find out what's 25% of 360 degrees. And that will tell me what angle this is. So, on my calculator, I'm going to multiply 0.25 times 360. And I get 90 degrees. I could have also divided by 4, because you know that there are 4 25s in 100. So we could have divided by 4. But we find out that arc AB is 90 degrees. Why? Because this angle is 90 degrees and the angle and the arc are the same. Let's look at arc BC. Arc BC is right here. And we know that that makes up 40% of our circle, or of our total pi. So just like we did with arc AB, we're going to take and find out what is 40% of 360. That will tell me what my angle is. I find out that 40% of 360 is 144 degrees, which means that if this angle is 144, then this arc is 144. Make sure I'm using the degree symbols again. Then it asks for arc CD, and arc CD is right here. And we know that arc CD makes up 10% of the entire circle. So just like I've done so far, I'm going to multiply 10% times 360 and find out how much it equals. And I find out, by using my calculator, it equals 36 degrees. Last but not least, I'm going to find out what arc DA is. And I can see that it also, just like AB, is 25%. And if that's 25% and AB is 25%, then it should be 90. Because AB was 90 degrees, and they're the same percent, they should be the same angle. But here's the question. If I do the arc addition postulate, what should all of these arcs add up to? Should equal a whole circle, right? Well, go through and add up the degrees. Is that what you get? Do you get a whole circle? When I add up all those degrees, those 4 degrees, I get 360 degrees. Which makes sense. I already knew that that's how it was going to work out, but that's what the arc addition postulate is. Now we can do the same thing here with finding out major arcs, like major arc A, B, C. When I take major arc ABC, I'm adding arc AB and BC, AB and BC. And so the arc addition postulate would just be adding 90 and 144. Or I could do the same thing with major arc, A, C, B, where I'm going from AD to DC to CB. And you're adding up those little arcs to get a major arc. The arc addition postulate is really, really simple. Let's go to the next page. The next page is a guided practice, and what I want you to do is take what you're given. Here, they tell me that AC and BE are diameters. AC and BE are diameters, which, let's just review very quickly. A diameter means, excuse me, it cuts the circle in half, and half of a circle is 180 degrees. What I would like you to do is I would like you to go through and solve for all these missing arcs, knowing that AC and BE are both diameters. Pause the video and solve that now. Okay, I hope you had enough time to solve for all the missing arcs in this problem. You'll notice the first thing I did was go through and start solving for my missing angles. Let me kind of backtrack and show you specifically my thought process. The first thing I did was say, if BE is a diameter, then these three angles should add up to equal 180 degrees. And if they add up to equal 180 degrees, then they're all supplements. 70 plus 40 is 110, which means this missing angle's got to go from 110 to 180, which means that it has to be 70 degrees. And then they also told me that AC was also a diameter, which means that it too has to add up to 180 degrees. And that if 70 plus 40 is 110, then this angle has to get me from 110 to 180, which means that it too has to be 70 degrees. And then last but not least, I figured out if the entire circle has to add up to 360, then I should be able to take 70 plus 40 plus 70 plus 70, which ends up being 250. This angle should get me from 250 to 360. So that's how I figured out it was 110 degrees. Now I go through and answer my questions. I know every angle inside of this circle. Now I can actually solve for my arcs. When they asked for arc BC, let me just finish doing this. When they asked for arc BC, I knew that arc BC had to be the same as the angle. And that's how I knew it was 70 degrees. When they asked for arc DB, I knew that arc DB had to be the same as this angle. And this angle is made up of 70 and 70, which is 140. That's how I knew arc DB was 140 degrees. Then I went to AD, which is right here. And this arc is made up of A, F, D, which is made up of 70 and 40. 70 plus 40 is 110. And that's how I knew arc AD was 110. Now, don't get confused that it should be arc AED, because when you use three letters to denote an arc, it should be a major arc, not a minor arc. Let's go to arc ACD. And arc ACD, A, C, D. Notice I didn't do this. I didn't go A, C, D. I went A, C, D is made up of this angle, which is actually made up of 110, 70, and 70. And when you add all three of those up, when you use the arc addition postulate, that's how I got 250. And then you can see that I solved for DC as 70, AE as 110, ABC as 180 because it ended up being a diameter, and then EAC as 250. Now, if you wonder how I got those, you can ask tomorrow in class. I solved them the same way as I did the top four, by the way. But hopefully this makes a lot of sense on how to solve for missing arcs, that diameters form semicircles, and semicircles are half a circle, which is 180. Major arcs are formed by multiple arcs, multiple minor arcs, and they're always over 180. Hopefully this isn't too complicated, in which case, let's look at our homework.